At the end of this video, you should be able to explain the significance of an activity series and use an activity series to predict whether a given reaction will occur and what the products will be. The ability of an element to react is referred to as the element's activity. The more readily an element reacts with other substances, the greater its activity is. An activity series is a list of elements organized according to the ease with which the elements undergo certain chemical reactions. For metals, greater activity means a greater ease of loss of electrons, thus forming positive ions. For non-metals, however, greater activity means a greater ease of gain of electrons, again to form negative ions. The order in which the elements are listed is usually determined by single replacement reactions. The most active element, placed at the top of the series, can replace each of the elements below it from a compound in a single replacement reaction. An element farther down can replace any element below it, but not any above it. For example, in the discussion of single replacement reactions in the previous section, it was noted that each halogen will react to place any halogen listed below it in the periodic table. Therefore, an activity series of the group 17 elements lists them in the same order from top to bottom as they appear in the periodic table. This is shown in the activity series on your screen here. As mentioned back in section 1, the fact that a chemical equation can be written does not necessarily mean that the reaction it represents will actually take place. Activity series are used to help predict whether certain chemical reactions will occur. For example, according to the activity series for metals that we see on the screen here, aluminum replaces zinc. Therefore, we could predict that the following reaction does occur. Cobalt, however, cannot replace sodium. Therefore, to communicate this, we would write the equation on this again at the bottom of the screen here. Solid cobalt reacts with sodium chloride in the aqueous phase to result in no reaction. It is important to remember that, like many other aids used to predict the products of chemical reactions, activity series are based on experiment. The information that they contain is used as a general guide for predicting reaction outcomes. For example, the activity series reflects the fact that some metals, potassium for example, react vigorously with water and acids, replacing hydrogen to form new compounds. Other metals, such as iron or zinc, replace hydrogen in acids, such as hydrochloric acid, but react with water only when the water is hot enough to become steam. Nickel, on the other hand, will replace hydrogen in acids, but not react with steam at all. And gold will not react with acid or water, either as liquid or as steam. Such experimental observations are the basis for the activity series that you see on the screen here.
An activity series is a categorization of elements based on their reactivity. For example, alkali and heavier alkaline earth metals react readily with cold water, oxygen, and acids. Lighter alkaline earth metals, aluminum, and some transition metals will not react with cold water but will still react readily with steam, oxygen, and acids. Some heavier metals will react with acids and oxygen but are unreactive to any sort of water. Other heavier metals will react with oxygen but are inert to acids and water. A few transition metals, such as gold and silver, are very unreactive.
At this point, you should be able to explain the significance of an activity series and use an activity series to predict whether a given reaction will occur and what the products will be.